Hey guys, it's OpenQuant here, and today we have question number 13, Portfolio Manager. So before I begin, I'd just like to say that I'm feeling a tiny bit under the weather, so if my voice sounds a little bit hoarser than usual, I apologize in advance. I hope it shouldn't interrupt the flow of our problem today. Anyways, let's get into this problem, Portfolio Manager, where you are the portfolio manager of a fund worth $75 million. Congratulations. You have 5 different asset classes that you can invest in. They're listed in the problem: equity options, futures, fixed income, event contracts, and cryptocurrencies. The question then asks us to count the number of ways that we can allocate all $75 million into each of these 5 asset classes in increments of exactly $1 million. This is a classic combinatorics problem where if you haven't yet seen a problem of a similar style or structure, it might be a little bit challenging to solve. Fortunately, you've come to this channel where we're going to go through not only the answer to this question, but kind of an intuitive understanding of problems of this kind of structure. So let's start with an illustration, or we'll do a little example just for, why not. So we're just going to abbreviate each of these asset classes. We'll say this one has 20 million, CF 15, fixed income 10, event contracts 10, and that leaves us with, for cryptocurrencies, 35, 45, 55, 20 million. Okay, 20 million in cryptocurrency. I guess that's just how this portfolio is going to go. Anyway, this is just a sample portfolio that is entirely valid, and the question asks us how many different ways can we order the 75 million such that the sum is equal to 75 in increments of $1 million, of course. So I'm gonna delete that for now. How would we go about this problem? So for those who just want to understand what the theorem or the identity is called, it's called stars and bars. Let me explain what that means right now. So we have 75, in this case, stars, which are we'll just 1, 2, 3. These are each $1 million. We'll call them 1, 2, 3, all the way up to 75. And the question asks us, how many ways can we partition these 75 million, or these 75 individual millions, into 5 respective cases or classes, or in this case assets? So like pictorially we could divide them up like this. We could say we draw a divider there, we draw a divider there, and then for the ones in between we draw another divider there and right there. So we'll just say that these 4 dividers right here have partitioned our 75 individual millions into how many different groups? Well, let's count them up. 1, 2, 3, 4, 5. All right, interesting. So in this case, to asset class number 1, we've allocated exactly 1 million. One of the 75 belong to this first asset class. For the second one, how many do we have? We have 1, 2. So this asset class gets 2 million. And again, I abbreviated here with these 3 dots, so we don't actually know where this divider lays, but we could say that this is 25, this is 25, and that would leave what, 22. Or I guess this last asset class, we have a divider right there, right before the 75th million, so there's exactly 1 there. We would have to rearrange, so 71 million for 2 asset classes. We'll say 35 and 36 million for these 2 asset classes. Again, we don't know where this divider was drawn truthfully, because we use these dots as annotation. The gist of what I just did was dividing up these 75 different components that we want to split, the 75 individual millions, into 5 different distinct sets using 4 dividers, because in this case 4 dividers partition our entire amount into 5 spaces. And this actually reduces to an interesting combinatorics solution where we actually have 79 total objects. We have 75 millions, 75 M's, and we have 4 dividers. And if you're looking up like a Wikipedia explanation of stars and bars, these would be the stars and these would be the bars, because illustratively these are literally bars dividing up the whatever it may be. So we have 79 total objects, and what we want to do is find the number of ways that we can order these 4 dividers amongst these 79 total objects. That would be, quite simply 79 choose 75. And completely equivalently, this is the number of ways to choose from the 79 total objects. How many ways can we choose to allocate the 75 M's? So this actually right here is our solution, and just to expand upon it in case you may just to reinforce the definition of this combinatorics definition, it's 79 factorial over 75 factorial times 4 factorial. So this right here is actually the number of ways to allocate our $75 million into 5 asset classes. Alright guys, let's now do part 2 of this problem, which asks us to count the number of ways to allocate the same $75 million, but now stipulates that each asset class has to have a minimum of $5 million. Alright, so the reason that we just can't use the exact same approach as the first problem is, well, because let me draw it out. I'm going to use a few more stars this time, just so that it kind of makes sense what I'm talking about. So these are all 75 of our stars, and just as in the first problem, we would have 4 bars to split up into 5 different classes. So the reason we can't just use the same approach is because now, let's say we pick our first bar to be there and our second bar to be there, let's say our third bar to go right there, and then we'd have our fourth one somewhere in the middle. The first asset class, based off of this diagram, would then have $1 million allocated to it. The second one would have, 1, 2, $2 million. The third would have 1, 2, 3, $3 million. The fourth is it's variable depending on where that is, so we'll just say X, and this will be 70 minus X, or this will be 70 minus X. Exactly. The reason we can't do this is just because the problem says that each asset class has a minimum of $5 million, and right now we have 1, 2, 3, which violate that requirement. So it's pretty clear to see that we can't just apply the exact same logic as from our first subproblem. However, there's a slight variation to the stars and bars approach that would allow us to very elegantly solve this problem. So let's erase this counterexample because this serves us no purpose anymore. If each asset class has a minimum of $5 million, we then know that we'll number these asset classes instead of me writing them out. At a minimum, there is 5 to each of these. And what this leaves us with is $50 million to allocate to the remaining 5 asset classes. Just, based off of the fact that we start with 75, we are automatically going to give 5 to each asset class, and 5 times 5 is 25, thus leaving us with 50 million, which can be allocated at will to the remaining 5 asset classes. We could, of this remaining 50, we could assign, all 50 to one asset class. We could assign 0 to one asset class. We could assign any number of arrangements of this 50 million to the remaining 5 asset classes. And this actually looks exactly like our original stars and bars problem. In fact, it is. Except now, instead of allocating the 75, we're just going to allocate the remaining 50. So we can use the exact same formula or solution methodology from the first part to get that there are 50 stars, in this case, 50 M's, which are, analogous to stars, and 4 dividers, just like before. And what we want to do is then count the number of ways we can split up or partition these 50 millions, and that we know to just be equal to 54 choose 4. We're choosing 4 of the dividers of the 54 total objects, also equal to 54 choose 50, choosing where to allocate the 50 M's based on the 54 total objects, also equal to 54 factorial divided by 50 factorial times 4 factorial. Great, yeah, that's the solution. There's really not much else to be said. I'm just gonna really quickly just run through an example of what this would actually mean. So we have 4, 5. Now we only have 50 m's to allocate. We have our 4 dividers. I'm just going to draw them kind of haphazardly. And as before, we'll have one somewhere in between. We don't know exactly where it is amongst these 3 dots. So this first one has 1 m. The second one has 2 m's. This third one has 3 m's. And these fourth and fifth don't know exactly how many m's we have allocated to each because of these 3 dots. So let's just focus on these first 3 for now. So that means that for asset class number 1, there are 5 plus 1 equals 6 m's allocated. For asset class number 2, same logic, 5 plus 2 equals 7 m's. For class number 3, 5 plus 3 equals 8 m's. So as you can see, what we did right here was just partition up the remaining after the minimum was allocated to each asset class. By doing so, we get the exact number of ways to partition our $75 million. Thank you guys for listening. Have a good day.